I am trying to make some rock climbing holds that are 3D printed. But if it's raining or it's dark, which happens a lot during the winter, I can't really test them outside. So I want to test them on this pull-up bar right here. But the issue is, right now if I take one of the climbing holds like this one right here, and I just try to attach it directly to the pull-up bar here, that's not going to work for you. So I need to make some sort of 3D printed adapter that goes from the pull-up bar here, probably attached here and here, so I can actually screw on the 3D printed rock climbing hose for testing purposes. So in this video, I'm going to try to walk you through my design process and trying to actually make that possible, and then we'll see what happens from there. So I got my pull-up bar here, and I got my digital calipers here. So I'm just going to go ahead and start measuring this. So it looks like this top bar is right around 25.2 millimeters. Measure that a couple of times just to make sure it's the same from all angles just about. I'm seeing the biggest that it's like 25.5, 25.6 maybe. But right around 25, right in there. It's maybe like 25.5. Somewhere in there. So 25.5 millimeters. And then the one below it, so this one, see what that is too. I'm seeing the same dimensions for that one. So yeah, right around 25.5 or so. So yeah, 25 for both. And there's an interesting design element we might be able to use as well here, which is that little metal peg right here, if you guys can see that. So we might be able to design around that to just have something to clamp onto, or like, you know, position it, more or less. And that is 10.1. It's like 10, 11, 12. I'm going to say 11 millimeters is like the outside edge for the hexagon. And then we can design around that. Okay, so yeah, got my dimensions down here. We're going to start by just designing something for this top part, and then we will try to make it attached to the bottom as well and just see how far we can get with this. So we're in Onshape now. I have my dimensions. What we're going to do is we're just going to start a new document where I can start trying to create this file. So go over here, go to document, and then I'm just going to do pull-up bar. So we know it's 25.5 or so millimeters for the actual cylinders that are going through here. And the hexagon on top is about 11 or so millimeters. So what I'm going to start by doing is we're going to make a sketch on the front plane here, just to represent this cylinder that we're kind of designing around. See if that works. So it's 25.5. I'm going to just make it 26. Because 3D printing is going to be a little bit not perfect on the dimensions, I'd say. And then I'll extrude that out symmetrically about 50 millimeters. Then also on the same plane, so the front plane here, I'm going to make another sketch and then just have a line that goes out. And I didn't actually measure how tall that hexagon is, but I'm going to just make it maybe 10 or so off the top of this one. So from here to here, I'm just going to make it 10. That'll be fine. And it's 11 millimeters, so that means that we need to make it half of that. So like 11 divided by 2, which what's great about Onshape is you can just do those math calculations right there inside of the actual CAD software there. And then I'm going to do a revolve, revolving this sketch area here around this axis. So selecting this, now we got our hexagon, quote unquote, there. So now we know exactly what we need to actually sketch around. And here's where I'm going to pause. I'm going to grab the pull-up bar again, just take another look, see exactly how much room we have that we're working with here. So looking at this again, right here, we have about how much space between this and the phone. And if we have to move the phone, we can, but I like to leave it if possible. And it is 14 or 15 millimeters right there. So I'm gonna say about 14 millimeters is how far we can actually extrude this out. So that's good to know. So going back to Onshape now, we know that we can have about 14 millimeters around this, and then we also have to wrap around this. So what I'm gonna do is start a sketch right here, and then I'm going to make a center point circle with the same origin point as that one that I just extruded a second ago. This is going to be 14 from this point here all the way out, which means we take 14 times 2, because that's just describing the radius. And that should work as a start, but I think that what we're going to need on this one is for it to expand out a little bit farther, because as you can see here, it's really not going too far over these edges, which we would like it to go a little bit farther out just to have that strength. So I will take a center point rectangle as well. It's going to be dimension to that, where it's still touching, so that'll just be a tangent constraint. So I click this, and I make a tangent. And then I'm going to make this, let's say, how far out is this? Take this line, I want it to be how far from here? And sometimes it doesn't give you the exact dimension you want immediately. Just gotta play with it. I'm gonna say 6 millimeters. We want this to be pretty thick. So 6 millimeters there could be good. Okay. So that's looking pretty nice now. And the next step's gonna be extruding it outwards. And we can make that go all the way down to the bottom of this. So that'll be fine. So I'm gonna try doing an extrude here and see what we come up with. It's going to be a new body. It's going to be going down, and if we can, I want it to go all the way down to the bottom of this. So that's not going to work, so what we're going to have to do is figure out a new way to do this. We know the distance between this plane and the bottom of this, because this is a 26 millimeter circle. So from here to here is 23. So 23 plus 13 equals 36. So all we got to do is extrude by 36, and we should be all the way there. Yep, if you look at that, that's all the way through, and it lines up just about perfectly. What I'm going to try to do is just see if what an intersect does, and yeah, that's not going to work for us. So I'll go back to new, and then do the check mark. Okay, so the next step, and this is where it gets kind of interesting, I'm going to label both of these. So this is going to be called the base, and this is going to be the, I don't know, adapter. I'm going to do a boolean between these two. So you just right click and then click boolean. And then I'm going to try to subtract the adapter from the base. So the tool is going to be the adapter, and the target is going to be the base here. That's wrong, so we're going to flip it. So the tool is going to be the base, and the target is going to be the adapter, I believe. And maybe not. We'll see. Ah, I see the issue. So it would result in a non-manifold body. That just means I need to extrude slightly farther and I can cut it back. So we're going to change this extrude to 37, 378. And then, see, that works now. And we can just cut that back 1 millimeter afterwards. Or maybe we can't. It's not liking us removing 1 millimeter because it'd be a non-manifold body for some reason. So I'm going to see if we can do move face and offset that by 1 millimeter. And it doesn't like that either because all of this is just creating a non-manifold face. There's got to be a way to do this. What if we extruded more than a millimeter? That could maybe work. Okay. Like, what about 1.1 millimeters? Yeah. So you can do like anything over a millimeter is just a millimeter exactly would screw stuff up for some reason. And since we're trying to 3D print this and have it like attach on top of it, we can't actually wrap it around properly. It's gonna flex a little bit, but it's not gonna be perfect. So what we're actually gonna be needing to do is slicing it so you just slide it on. And it matches the top, but doesn't perfectly fit the bottom there. So I'm going to focus on the plane by pushing the N key. And then select this, push U to project it, / convert. And then we go down here. And yeah, just trying to cut off these bottom parts so that it connects better. Extrude that out as a cut through all. And that should hypothetically work. I'm going to check how tall the silver bit is now, just so we can make this as accurate as possible. Just using the bottom bit, the caliper here. And I'm seeing 11, so we'll see how far off we are currently from that. So from that line to the top is 10, and it's perfectly fine for it to be sticking out just a little bit there on the top. So I think this should be good to go to go ahead and print it. I'm going to chamfer the bottom just a little bit. You don't need to do that necessarily, but it can be nice aesthetically. Just make it 2. I don't really want it on the bottom. Just make a line up. Chamfering can also help you with 3D printer adhesion and everything else. I'm using a Bambu Lab P1S, so I don't think it's going to be too big of an issue, but it's good to have just in case. And then to give it some tolerance, I'm going to do move face command on all of these surfaces and just give it 0.2 or so it probably fits a little bit better there. So yeah, just move everything out by 0.2. And make sure that you're moving it out, not moving it in. So as you can see there, I almost did it the wrong direction. This will be moving it out, this is moving it in my case. So that should be good tolerance. Okay, so now that we have that done, I'm going to rename this to be pull up adapter V0. I like to just do that as my naming scheme. Export that as STL, and we're gonna open up my 3D printer here. And this should be fine for the A1. But I'll probably do it on my P1S just because it has the 0.4 millimeter nozzle right now, which might be a little bit more precise than the 0.8. Just switching the profile, discard the values. And I'll make this standard because we're just checking fitment right here. We don't really need it to be super strong necessarily. Okay, so then dragging this in, auto rotate, arrange, make sure my filaments are synced so I have my actual options here. And I'll make it out of white. I generally like to do prototypes out of white where possible, just because that makes it a little bit easier to write notes and such on them. As you can see, that's not perfect because, 3D printing technology and everything. We might be able to rotate it on its side to make it a little bit better, but then the hole would be messed up. So for now, I'm going to just leave it, and then in future editions, we can change it out to present it just a little bit nicer. So PTG2, bed leveling and A1S, that's fine. And then I'll just send that, and it'll be done in about 40 minutes is what it's saying now. So hopefully I can come back to this sometime tonight and keep on working on it, but we'll see what happens from there. And once we get done with this, if it fits properly, then we can move on to trying to attach it to this back piece, which is the plan. So it'd be at the bottom of this 25 millimeter or so circle. It would hook into this back piece as well to offer additional support. And then I'm still deciding where I want the actual part that you attach it to hang out from. Thinking about going a little bit wide on it, so like coming out from this direction and just having the part where you attach your climbing hold on both sides of it. But I could be convinced to go the other way as well. Just could be a little bit cleaner with the foam. I want this to still be functional as a climbing, as a pull-up bar, I'm saying. But also whenever I need to just test the climbing hold, then it'd be nice to have this as an option as well. All right, here's the new setup, by the way. I moved everything around a little bit, so now I have the A1 Mini over here, SB08, and then my P1P right here. Here is the first version of that adapter that I designed. So you can see it came out pretty well. And yeah, looks pretty good. So then we're gonna go for the test fit. So this is my first time trying it on camera, and it looks like we are definitely off there. Yeah, this just seems like it's too long. Like, it's going down and then it's hitting this foam and this metal. Before I would call that to be like anything close to a secure fit. You can see how much air gap there is right here. Yeah. So we're gonna have to definitely cut that down some and just see where that leaves us. The size for the hexagon though, that seems fine. You can see here there's no clearance at all there. Like that's flat against the bar. So the hole for that's fine. It's really just these legs on either side of it are a little bit too long, which I don't know how that got miscalculated, but I'll take a measurement on that and then we will go back into Onshape, print that out, and see how it looks. So obviously this is off somehow, but we need to figure out exactly how much it's off so we can adjust it. So I'm looking at this with my calipers right now, and it looks like we're off by about 3.6 millimeters is what I'm seeing. Somewhere in that range. What we can do is we could also just try to cut this up with a pair of scissors and then see where we're at. But 3 millimeters or so sounds about right to me. I'm going to check it this way too. And just see if I can. Maybe as much as 5, I don't know. I'm going to say, let's play it safe. I'm going to play it safe. I'm going to do 5 millimeters off. And then we'll just go from there. The fitment seems fine. I mean, I think that the amount of tolerance that we did is okay. Like if you look at this right here, there is some wiggle, but not too much. We could honestly probably cut it down to like 0.1 millimeters, but we'll leave it as is for now. I'm just going to cut off 5 millimeters from the bottom here. I'm also going to, what I like to do with all of my prototypes is I like to mark down the name of it and like the date. So this is going to be V0. You don't have to do the date, but sometimes it's nice just to have so you know when this project started. So you can see there it says V0 and then it has the date on it. And that's just going to show me that this is the first prototype. I'm also going to mark down what's wrong with it, which is why I love using white plastic for prototyping, is because it's very easy to draw on. If you use black, you can use these white paint pens, and those work really well for marking down stuff, just little notes and everything on it. But I prefer the Sharpie if I can with just white PLA, white PETG for note taking. So I'm going to write too long. So you can see right there, just have it written too long, and that's going to show what the issue is. So if I ever look at this prototype again and I see it's V0, I have the date, I know what happened, then I can kind of follow along with the project if I need to. So I lost my OBS recording for some reason, so I'm going to show you exactly what I was doing in CAD there. So right here, you can see that this is a little bit too long, like I was showing in the video a second ago. It is 35.9 millimeters from top to bottom. What we want to do is cut off 5 millimeters here. So I'm just doing that using the extrude tool. I just selected both of these two faces, and then as you can see here, we're cutting off 5 millimeters. So that part that's like kind of translucent is what we're cutting off. We're just cutting off 5 millimeters. And then all I did past that was I go over to the slicer here. I dropped in the new file, which is this white one. So it is V1 right here, and then just slice it and send to printer. I also like to rename it, so that's where I did right here, just to make sure that I know exactly what version it is. So whenever I'm printing it out, I can mark it with the Sharpie, like I showed a second ago, so I know exactly what's happening. It's like, this is the version in CAD, this is the version here on the printer, and there's like some sort of miscalculation, you know what's happening. Sometimes I like to duplicate the file, so I can have like V0 right here, and then V1 next to it, so I can see like visually the changes between the two files. But I don't really think that's necessary for this case, since it's such a minor change and like not a very complex assembly or part. But yeah, hope that's helpful. So I skipped some steps, but now we're back with the next version of this, which actually has the hole for the climbing hole to go on. So you can see that it came out pretty well. I'm going to test fit that on the pull-up bar here. And I'm not very confident that this is going to actually work first try, but we're going to see what happens. So place that on, and we have the hole right here for me to attach the climbing hold to. I don't, I don't think that's going to support my weight. Pretty confident that that's going to make me fall, and it's probably going to suck, but I'm going to test it. Okay, so it broke actually when I was trying to attach it. So we're gonna have to go back and reprint this a little bit stronger than it is, and also drop it down a little bit because it was not wanting to go on there with the tolerances that I have right now. I was putting it on here like this, and I had to physically move this climbing hole to the side in order for it to slot on here. So that's just not gonna work. We need to make it a little bit farther out, and yeah, we'll take a look at that. All right, so we're back in Onshape now. This is the new file here. And the issue that we ran across is, as you can see, this broke. And the reason it broke is because whenever I was trying to attach it, this part was interfering with the pull-up bar. So I had to try to twist the climbing hold, which produced a lot of stress on this point, and then it snapped. Um, I think the solution here, the easiest thing that I can think of just right off the top of my head, will be just moving this down like 30 millimeters. I still don't know for sure if it's going to be able to hold my weight. I feel like that's kind of maybe not, but I think that's probably the first thing that we can test here and then go from there. So in Onshape, we're looking around, and it looks like if we want to move this hole down 30 millimeters, that's going to be a little bit of work. So we go here, looks like that's sketch 11, And what we can do is we can just drop this whole circle down 30 millimeters from where it is currently. So I'm going to make another circle that is 30 millimeters down, center to center. Should be fine. 30 millimeters there. I think that should be enough. Trying to think. Yeah, I would measure it center to center distance. Yeah, so that should be good, I think. Or maybe this is 10 millimeters, so I'll do 35 millimeters. And then I'm also going to make sure that it is 16 from here to the bottom for the next line here. And we will go from there, see what we can do. So dimension this 16, and then just make this line come down. Although that looks ugly now. But it's fine, this is just for testing. And then let's make those lines as well. And that's going to let it have kind of a teardrop shape, which will be good for printing. And then extrude 16, extrude that, fill in those. And that should work. Oh, I'm looking at this and like, I don't know if I can see this working. This is a really ugly design. A lot of the force is going to be right here as well. So what I can do at the very least is I'm going to come in here and I'm going to try to connect this and this, which should be fine to have like a pretty steep angle between this corner and right here. That's going to just help a little bit. And then I can also go from here to one of these lines. Or let's just see what that angle is like. That might be fine. So I flip it. That's definitely better than like a 90. What if I just go from here all the way down? Yeah, that's better than a 45, and that connects all the way. So I'm gonna say extrude that, and then that's going the wrong way. Add that on. Subtract that, add that on. And then we're going to also go back to the same sketch and cut out this through all. And now we got that shape right there. Still doesn't look great. And I'm not very confident that that's going to be able to hold a climbing hold hanging down from it with my entire weight on it. But we can definitely try it and see what happens. So that's 16. We need to change that right there to, I think extruded 25 and he's only extrude 16. Okay. Only other thing I'm thinking here is maybe connecting this all the way through onto here. That could help, but I'm not sure the best way to approach that right now. So we'll leave that for later, and we'll just start with this and see how it works, see where it breaks, that kind of thing. So I'll change that to V5 here. And we'll see what happens. I'm thinking that the best solution for this might be something kind of funky, like if we were to potentially have it where it's like two separate pieces. That might work for us, but I really don't know at this point. So I'm going to auto rotate that, change it to white again, and then we're going to change it from standard this time to strength. Just give it a little bit of extra strength there. 6 walls, 25% grid infill. And we'll see how long that takes to print. So 2 hours, 49 minutes for this, and then 94 grams of material. And we'll see if that can hold me. I'm not confident, but maybe. We'll see what happens. No matter what, there's got to be some way to do this, but I'm just not sure if this is the best way to approach it or if I should look at doing it some other way. Okay, so I was thinking, you probably don't want the center weight to be off axis from it. You want the weight to be directly under this thing. And I think we can design around that. So what I'm going to try to do is design this in parallel while the other one's printing, and I'll get this one going off of the A1 Mini and just see what happens. It's also going to be a good test of the 0.8 millimeter on some like more detailed oriented printing. I mean, not super detailed, but a little bit more than rock climbing holds. So I'm going to start by duplicating this file, and then I'll rename this, I don't know, V6. Or I'm going to just say pull-up adapter test. It's just a test right now. And then we're going to delete all of this crap. So right here looks pretty good as a starting place. So what I want to do is expand out these sides here. So I think that's just cutting those off. So we don't want that either. So I'm going to expand these sides out, and then I'm going to try to make a mechanism where you basically have this, and then you have another piece that goes in and slots into it, and then the weight's hanging below that. And we'll see how that looks. So how wide do we want this to be? I'm going to say we want it to be 4 millimeters of like connection, at least. So we got to push it out a little bit more. I'm going to say, and this is a great time to use the move face command, because that lets you move both sides at the same time, which you can't do with the extrude tool. I'm going to say if we want it to be 4 millimeters of like actual like inserted area, then maybe 8 millimeters out could be good as a starting point. And we can always come back and adjust that if we need to. So how long is this now? This is now 13 millimeters. So you put 4 in the middle of that, and then that's 4 on each side. That's pretty good. I'm going to actually cut that down to 7 just to make it 12, make it a little bit more even for us. And then we can try to go from there. Although, I need to test something first. I need to see how wide the foam is. 1 second. So we got the foam right here. And the foam is actually right around 30 millimeters. So that's going to be adding 2.5 on each side that you can't really use, like 30, 31 millimeters. So with this being 10, 4 on each side, it should still be fine to be able to like flex around that. So I'm going to leave it as is for now, and then we'll just go from there on the design file. And if we need to change something, we can, but there's no chance, or we don't even know if it's going to work yet, so it's fine. So it's 12 by 43. That works. Then I will select that to start a sketch plane, go on top, and then what we're going to do is make a little box here, off by 4 from that side, and that side, just every side off by 4. And you might be saying, Boaz, this would be a really great time to use the offset tool. And I would say you are absolutely right. That's what I'm going to do right here. Okay. So this is 4 millimeters by 35 millimeters. And I think that could be a good start for connecting it. I kind of want it to be a little bit more bulky, but I think this could be a good start for just seeing how the concept works and everything else with it. So I don't want it to go all the way through necessarily. Although if I do, that could make it easier to print. Let's go all the way through on these and see how that puts us. So select this one and this one, remove through all. And now what we need to do is make something that actually slots into this and then goes down the distance that we need, which is from the bottom of this to the bottom of this is 100 millimeters. So we'll look at that. We'll look at something right around there. And how I'm going to design that is probably start right here and just sketch out what we need. So from the bottom, it's going to be 100 millimeters. So from here to the bottom is 100. And we don't want any of the circle area, so we can just select those lines, push U to convert them, and then go across here. And then we can extrude these two and just cut it out using that Boolean tool I was using earlier. But we actually needed to wrap around. So we're going to make this rectangle just a little bit bigger. I'll make it 4 or 6 or so. Just wrap it around there. It's going to kind of come out, up around, and then go back down. It's kind of the general design shape. So I want it to be at least 4 millimeters here as well. Oh my gosh, it's a tiny little, yeah. So at least 4 here, 4 here, 4 here, and then just kind of going down towards the middle, which is going to round out as well, ideally. And I'll have the circle, which is going to be 16 off from the bottom like we did on the last one. So 16 here, and then make another circle that's tangent to it. Those two can be coincident. And then just make a line that goes down to that, goes down to that. And yeah, let's make these a little bit thicker. I'll do maybe 6 here, 6 here, 6 here. And just see where that puts us. I think it could be good. Okay. So I want it to go the other way, all the way to this face. Or really, we just wanted to go from this face to this face, and then we're going to offset it a little bit. So we needed to like hook down inside of it. I've never had to design something like this specifically before. But yeah, definitely want to start from this. I want it to go to this. And then we can just tolerance it afterwards. Okay. That needs to be a new shape, not a add function. Okay. So that's obviously a problem. We don't want it to be going down inside of it. So we change the sketch here to also cut out all of that stuff. We don't want it hitting any of that either. So really, all they want is for it to go into the slot and then stop after that. So like that, then like that, all the way up. And yeah, let's see where that takes us. Oh boy, so that doesn't look good. Get rid of all that, and then we want to extrude that, and that, and these, and that right there. Sometimes you really can't tell what you're selecting. And that right there. Let's see what that looks like. So that's slotted in. Looks like. And that's what we want. But we can't, we got to cut out those slots so it can actually go in there as well. Because right now it really just, that obviously can't go in there. So the slot is that long. That's the whole length of it, which is 31 millimeters. So we just make it go down 15 millimeters. And it should have enough wiggle room to get in there, I think. So let's go down to sketch 14 again. Then, yeah, that's 31. So we'll just cut a line across at 15 from here to here. See how that looks. Okay. So that could work. I don't think that it's going to be strong, but that could work. And my camera's about to die. 1 second. Okay, so we're back in Onshape. I didn't record some of the edits that I made to the shape, but basically we're just trying to optimize this a little bit by reducing filament usage and then beefing up some of these areas so that the areas that are actually going to get force on them is going to be just a little bit stronger for us. So I got those 2 prints that I was talking about done. So here is the first one. The overhangs on that are just pretty awful there. You can see how bad that is. But this part came up pretty well. So we can test that out. Just all these overhangs are just really bad. I don't know why. We can look at the angles there. Maybe there's something we can do to improve that. Then we got the other alternate design that I talked to you guys about. And that's this one right here with the 0.8 millimeter nozzle. So this part feels tough. Like that is solid piece. And this part with the supports, I don't know how well the supports are going to come off. Let's see. So that's not too bad actually. But we'll take the rest off of the table. Okay, so this piece got screwed up pretty majorly. You can see how with these slants and this piece which is supposed to hook into it, it just doesn't connect. There's not enough clearance here for me to connect these 2 pieces. I'm going to try to cut it back with some like filament clippers here so I don't have to reprint it entirely, but I may just have to redesign and reprint that. That was stupid. I should have looked at it more. Okay, I had to trim it down a ton, like so much. This is just eaten up. It's awful. But I did get it to the point where you can slide it on if you hit it a little bit. So that's good. That's progress. Okay, so I haven't tested this yet. I actually don't know if this is going to go on properly. So I'm going to try it. So put that right there. That's on. This is where you hold on to it. So this is gonna be my first time actually grabbing onto this and then trying to support my body weight on this little hold. I'm gonna switch it over to the other side, so I can at least use my right hand. And now we're gonna see if I can test climbing holds at home using this. Um, I got glasses, but if this explodes, it's probably gonna just like go everywhere. So hopefully it doesn't do that. Uh, 3. I'm gonna hold on to this with my other hand, so I'm just putting on my weight on the right side first, and then I'll do both. 3, 2, 1. Oh, okay. That kind of hurt. Oh yeah. So you can see right there, that is just fully off that. That exploded with some force. That hurt my hand some. Okay, well, that design doesn't work, at least not yet. I could maybe make it stronger. But yeah, that did, it's just nasty. Did some work on it. It did not work. Okay, so that sucked and did not work. Now we're gonna try this one. So we're gonna put the hold on that and then see if that does any better. I don't know how many of these I can do today because kind of hurt my hand. Let's go. There we go. But I might need to wear some better safety glasses too. I don't know, just like it exploded with a bit more force than I thought it would there. It doesn't matter what side of this that I do. I don't think one side looks a little bit cleaner, so I'm gonna do with the bottom. Just need to tune in some settings still, but either way. So put this through. And part of this design too is that it has a lot less room for the climbing hold to actually grip onto. I feel like not like significantly, neither one of them has a ton of area to grip onto, but that is something to improve if this one doesn't explode on me. And as I'm looking at this now, I'm realizing the bolt doesn't go through. So either I need a longer bolt or I need to make this thinner because this is just the bolt's not going through. When I bought all my climbing holds and such, I also bought a variety pack of bolts. So I think one of these is probably long enough for this to be okay. Uh, but yeah, I'd suggest doing that whenever you buy your bolts. If you're planning to do weird stuff like this, the variety pack might be a good idea. So this is the old bolt on the left, and this is the new bolt on the right. So significantly longer there. And we'll see if that can stick through. I'm gonna say this is probably, you don't want to get too long either, or else it's not gonna thread properly. So that's gonna work right there. It's fine for it to stick out quite a ways from the bottom. It doesn't really matter there. Well, that's good. I knew I wanted to buy the variety pack, but I didn't know how useful it'd be just so soon. And then just trying to tighten this back up. See if I can get it on there good. Okay. So can I move that at all? I can still move it some. So I'm gonna put that a little bit tighter. It's not gonna be perfect or anything, but a little bit tighter could be good. I'm gonna call that right there. I think that's about as good as the last one. And we'll try this one now. Assuming I can get this to fit back together. If I had to guess, I would say this one has a better chance of working than the last one. I'm still not confident that's gonna work. So here's what I'll do. I don't think I can put it together. I think I have to put it together when this is already up there. So I'll start on the right side this time. That's on. It's rubbing against this foam a little bit, but that's okay. And then I'll try to slide this on. Okay, and that's attached. I fell into those 2 holes that we designed. And like I said, the idea with this design is that all the weight is going to be going directly from the bar down. So hopefully, at the very least, it's gonna break in a different place. Ideally, it works. It just kills my whole body weight. But worst case scenario, like it does break. Hopefully, it breaks in a different way, and we can learn something from it. So same thing as last time. Left hand over here, right hand on the hold with the holder and everything. And we'll just see if I can put my whole body weight on it. Kind of scared. Last one exploded. Okay. So that's good so far. And then letting go with the left hand. Oh, okay. So that broke too. Oh, ow. Head on my butt there. So where it broke is interesting. You can kind of see it's in the mirror part would be right here. And it's in the thin area. So if we want to go with this design more, and my gut's saying, yeah, it's probably better design than the first one, then we need to try strengthening this area, or we can change our settings. So right now I'm doing 0.8 millimeter nozzle. I want to say 3 wall loops, 3 or 4 wall loops, and then 25% grid infill, or gyroid infill. Actually, you can kind of see the waves just a little bit in there, I think. But yeah, we'll go with that. We'll see what happens. All right. So we're back in Onshape now, and I'm gonna show you exactly why it messed up. Which looking back now is pretty obvious, I feel like, but I'll show you what I found. So if you look here, you can see that this looks okay whenever you actually have it connected here. The issue is not whenever it's connected, it's whenever you're trying to connect it. So I try to move this up and down a little bit. You can see it still looks mostly fine, but this area is kind of a problem. And if I go into a section view here, you're going to be able to see that a lot clearer. So if I just section this off like so, I'm going to push the little check mark here. You can see wherever it's in red, so like right here in this area, that basically just means that like we have a problem. Those 2 pieces are interacting. And because this is just 3D printed plastic, like you can't have those pieces interact. So what I need to do is make it so that whenever I'm dragging this on it, it's not going to have any interaction areas where it's red. Yep. So that should be a pretty easy solution. I just need to figure out basically the distance between here and here, and then make sure that on the other part I have that much clearance to actually be able to slide that in. So let's take a look at that. And then we also know that the area where it broke was this area right here. So we're going to try to make this area curved and maybe toughen that up a little bit. Look at some print setting changes that we can do to just really reinforce that. And then hopefully I can hold myself up and not fall down again. So going back to the file here inside of Onshape, I'm going to be able to look at all of this a little bit closer. So I'm going to start by hiding the adapter, and then what is the distance between this and here? That's 16.2. So we need to just make that cut down to 16.2, and then we should be in a pretty good position there. When I say change that dimension down, I'm just saying from like the top of this to the bottom of this. And this shape is not helping us at all right now. That's 12 right now. We need to be 16.2, and we'll go with some tolerance to like 15.5 or something. It's probably fine. So I'm going to go back into this sketch since I already have one, and then just make a line right across here. and then do like 15.5 from the top here. See where that puts us. That looks about right. So I'm going to just drag this all the way across and then cut out these areas as well. So now from the top to the bottom of this is 15.5. So we go back into our assembly here and then put this back in here. We can kind of walk through the steps and see what it looks like. I'm going to edit the section view just a little bit to push it back a little farther. And then let's take a look. So it looks like I should be able to just slide that in there. If we go to the left view, you can see the spacing here, where there should be enough here for you to be able to slide in. It's still a little tight, and maybe I should cut it back just a little bit, but I think that this should be fine for what we're doing. I might cut it back to 15 for this first test. Yeah, I'll cut it back to 15 for this first test at 15.5, but it should be able to slide on properly this time, that's the step in the right direction for sure. So going back to that last sketch, I'll change it from 15.5 to 15, and then boom, that'll work. And then the failure point seemed to be right here. So looking at this, I want to say sketch 14 is where all of this happens. Yep. And it is kind of messy. I'm not going to lie to you. It's a little messy. I also did the move face thing that brought it back out another 2 millimeters here and just like all around. So what I'm going to do is, looking at how that's the issue area. We can play with this a little bit. Right now between this and this is 7.6 millimeters. Let's try to get that to like 10-ish. So I'm going to change this move face from 2 millimeters to 5 millimeters. Just make it a little bit thicker there. Then on this corner here and this corner, I'm going to round those out some. Let's do like 3 millimeters maybe. It's like a decent size curve there. Okay. And then let's go back to the assembly and see how that puts us, because that's going to interfere as well, which we don't like. So it might make sense to bring that out just a little bit so we can have that fillet. I think that makes sense. Or we could try to cut down these walls here some. Let's see. I think the easiest thing to do here might be to just cut the corners of this off just a little bit. I think that wouldn't hurt it at all, to be honest with you. So what I'm going to do is just go here, here. We could even just chamfer the edges, I think. So if I just went here, so yeah, a little chamfer there. That works. And then we go back to the assembly. You can see how that's going to help us with it just hitting the corner there. Okay. So that's looking good enough to me for us to go print it again and just give it like one more shot with this design. It's a little bit thicker now. We got it where it's right about 10 millimeters from the wall to here. If I just select here and here, it's like 11 millimeters. So a little bit thicker. This area where it broke is curved, so it's not going to have all the force right at that angle. It's going to be spread out a little bit more. So that's good. And then what else can we do here? I think that's looking pretty good for now. If this isn't strong enough, then maybe I just need to change print settings and I can get it there. But let's see if it like at the very least breaks in a different spot. Because that would be some sort of information for us on, just whether or not this design is any stronger than the last version of it. I want to say it definitely is. We've strengthened this area here where it broke last time. We curved all that. And then we made it so it's going to actually assemble without having to like chop it to pieces. But yeah, let's give it 2.5 hours. Take another look at this and just see what happens. And we're going to be printing this again with the PTG high flow. Okay, I was not impressed by the print quality, the way they orientated it this time. But I'm going to try hanging from it on this new one now and see if this one supports me with the new settings. So both hands on right now. And then switching to just the right hand. It's kind of rotating on me too. Oh, it's really rotating. Try one more time. Oh God. I think that's it. I think that might be it. That's super cool. That might be it. Okay. I'm scared, dude. It's falling on me twice now. Okay. Both hands on it. That's me. That's all my weight on it. That works. All right, I gotta go, but that works. We'll look at this more. That's awesome. All right, so in that glass clip, you saw that it worked, but it wasn't a very good angle. You didn't see the floor or anything to make sure my feet are like actually off the ground. So I'm gonna do it again, and you should be able to see everything now. So I trusted a bit more this time. I'm gonna just go straight for it. And look at that, feet up. Oh, so that's good. Yeah, the next steps for this is the way that this printed makes it kind of difficult to remove, like separate these two pieces. And that's just because it was printed out at that angle that I showed you in the slicer. So the next step is going to be printing with the supports again, or maybe modifying the design there. And then also, this is able to rotate more than I like. Like you might be able to see there where it's just rotating a decent bit. That's obviously not good. And I think that we can fix that by just increasing the amount of area behind it for this to grip onto. That's an easy fix there. It may limit if it can be printed on the A1 Mini. You have to have like an A1 or a P1P or a whatever else. But I think that's worth it, and we can just have this as a variety as well there. But that's big progress. That's really cool. I'm also going to try printing with a 0.4mm nozzle and the strength profile. Just make sure that prints on like a normal nozzle, not just a 0.8. Because 0.8s are supposed to make stuff a little bit stronger. But yeah, this is big. We got a couple more things to change, and then we got it. We got it. We're almost there. So I'm going to demonstrate just how awful this current connection system is. You can't just slide it straight out. You got to kind of hit it pretty aggressively in order to get these two pieces separated there. And then, now that this is separated, you can see that the print quality is also not great on that. Hopefully that's at least kind of visible. And a lot of that's just due to the angle that it was printed at. So I'm going to change the angle to back where it was, where it just has supports underneath these two pieces that come out. And I'm also going to increase the surface area on this, so it's covering more than just this little section here, and more of this whole section here, just to give it some more friction and actual stuff to hang on to there. I got a couple ideas. We'll see what actually works. All right, so it did work. We were able to hang on it, which is big, but there's a couple of issues still, mainly that it's kind of rotating on it, so it'd be good to have more surface area, maybe some kind of texture. We can figure that out. And then the print orientation on this version of it was kind of bad, and you can just see the print quality is not very good. It's like really hard to put together. You can do it, but it's not easy. And the earlier versions were better about that. And it's because the print orientation was better. So we're going to fix that, and that's just inside the printer. And then on this, we're going to try to increase the size of it just a little bit. Not too much, but just a little bit in order to accommodate larger holds and just give it more surface area to have some friction on. So we're looking at this right here. we can see that right now it's covering a very small area of the back of it. If we wanted to cover more, we're going to have to expand this out some. And because this is more about surface area than actual strength, I don't think we need to go all the way through it. Uh, it just depends on how we want to do it. But I think either way is possible. So what I'm looking at right now is taking it from its current size to maybe an additional 30 or so. I'm reading, it just depends how big we want to make it. And it's going to be going out on these sides, but not on this side, or else it could start interfering with where the fingers are going. And we don't really want to have the edge there if we don't have to, I would say. Doesn't really matter too much, but I would say expand out those directions. So let's take it to CAD, see what we're looking at. All right, so I spent a little bit of time looking over how I might be able to make this better, and just talking about how to increase the area and like the grippiness of this on this so that it grabs into it a little bit better. And I think that one way to do it could be adding some spikes and then also adding a bigger area. I said earlier that's going to be about like 75 millimeters, I want to say. So to start, I just made a sketch that was a circle based on the same center point of this other circle. I then extruded that out as just a new shape, which makes it a little bit easier for me whenever I go and try to like cut it out so it's not interfering with this. Then I just made another plane that's right through here, right in the middle of it, and that's just doing plane and then plane point. So basically you tap on this other plane over here and then this point that you want it to go to, which is the center of the circle. Then I just made a little sketch, which is cutting out this area right here, which you can see inside the revolve. And then I just used a boolean in order to combine both of those. So now this shape is all orange and that's all one part, so it's going to be printed easier. Then I took it down and made this sketch right here, which is just a line going across with a bunch of different spikes. I ended up not using this method and instead went for this thing right here. So as you can see, there's a little circle here, which whenever I revolve becomes one of these spikes, which you can then pattern linearly going in to make a series of these spikes, and then a circular pattern after that, which then expands out like this. I don't know how well this is going to print with the 0.8 millimeter nozzle. I'm not super confident in it, but whenever I went to the slicer and with a 0.8 millimeter nozzle here, you can see that whenever you slice it, it does look like it can print it, although it is cleaner on the 0.4. And I'm going to just be using the exact same settings as last time, so 3 wall loops and then 25% gyroid infill, but that's going to be a lot more surface area. You got some spikes here. I'm also going to be printing this part again as well, even though I haven't changed it, just so that it's the proper orientation with support going up on the sides there. And I'll also be printing both of these in 0.4 millimeter nozzles as well, just so I can also compare the strength between a 0.8 millimeter nozzle and a 0.4 millimeter nozzle. So whenever I'm done with all that, I'll be able to have two that I can test. I can test 2 holds at once, which means I can be hanging on just holds, none of the pull-up bar, which will be great. And we can also test between the 0.4 millimeter nozzle with the same amount of walls thickness and same settings for gyroid infill and the 0.8 millimeter, and just see what happens there. And if it can grip this a little bit better, where it's just not rotating as easily, then I think we can call the project done for now. I got some more ideas later on, but for now, I think we can finally be done with it, which will be great. Okay, these are hopefully the last 2 prints. So we got this one on the A1 Mini, that's white. And you can see these spikes are not very pronounced. They're kind of just a jagged, smooth line. But I think that does give more, I'm just running my finger around it. It does give more friction and resistance to movement than just the flat. So hopefully it still works some. And then we also got the one over here on the P1S, which is a little bit better. Oh yeah, that's really spiky actually. I'll show this on the table as well so you can see it better. But that's really spiky. That's going to work good, I think. And then I did a little bit of green, a little bit of black, just to use with the rest of my green. And it worked out pretty good. Okay, so here's that texture up front. You can see just like all of these little spikes on it. And if you run your finger over it, it grips it really, really well because these spikes are actually
pretty well pointed. I wish I had like a macro lens or some sort of digital telescope. On this, it's better than just running your finger along this, but I think that I have to make the spikes a little bit taller and more pronounced because this is just all running into each other with the 0.8 millimeter nozzle, which I kind of saw on the print preview a little bit, but yeah, that's just nowhere near as good as this. This is really good. So I'm gonna remove these supports and then we'll do some hang tests on both of these. So I got both of these hung up now, and we're going to try hanging on it individually and then together. One thing I didn't mention earlier is that because this black one is a PETG hold instead of TPU, I'm not sure how the spikes will affect it because of different materials, but I'm pretty confident that both of these are going to hold on fine and not rotate. That's my assumption. We'll see what happens. So I'm going to start with hanging on to just this right one and see if I can get it to rotate. So, going. And yeah, if I pull on the edge here, it is still rotating on this white one. And if you remember, the white one's the one that has the not as pronounced spikes. So if I switch this over to the black one, we'll see how that looks. See if that's any better. And I think TPU and the more pronounced spikes would be the best combination. Just haven't tried that yet. So hanging here. Oh! That actually broke in a new spot. Okay, well that's interesting. So whenever I put the... Okay, let's look at that. It broke here on the like little holder attachment thing, not on the white part. Whenever I put all my force here on the left side of it. So it was really pulling into this and supporting all of it just on that layer. That's interesting. So I'm going to try with the white holder here. Should be the same result. But the hole didn't rotate, so that's a good step in the right direction. And you can still... Oh no. That broke too on the 0.4 millimeter. Look at that. So on the 0.4 millimeter, it broke here. This video might not be done. Oh man. So it broke there and let's see. Yeah. So both of the holders have broken on this part of it. And this also snapped off the 0.4. Well, that's not good. We're gonna look at this a little bit more, see if I can get this beefed up, but yeah, I don't know. It's weird that like the first test went so well. But now, I mean, neither of these, this one's not rotating. So maybe it's just that because it's not putting the force into rotation, it's instead transferring it all to like right here. Because on the other test, I was hanging pretty much straight down below it. I wasn't trying to do off axis at all, but yeah, we'll look at it. We're gonna beef it up some. So looking at this again, we know what's wrong. We have two of these that are breaking the exact same spot, which is whenever they're hanging like this part is being pulled down and then separating. It's separated on both of them in the same area. So what we can do is try to beef up this area. And you can also tell, if you look kind of closely on that, that it's breaking along the layer lines. So it's being stacked up like this, like 1, 2, 1, 2, just all the way up. It's breaking along those lines and pulling up separately. What you want to do to increase strength inside that scenario, I think, will be changing the print orientation to like this, and then stacking up where it's all going to be loops going around, essentially. And that could make it stronger. I think that should make it stronger in this case. So I'm going to try to redesign it to be beefed up in this area and then also printed inside this orientation. The biggest change there is just going to be changing the circle a little bit and then also cutting this off so it doesn't have a overhang right there. But other than that, I think it should be pretty minor changes. Since this definitely performs better with all the spikes that are actually printable on the 0.4 millimeter nozzle versus the white one. This one didn't break. I do think that the 0.8 is definitely a little bit tougher than the 0.4, but what we're gonna do is look at where this part broke, which is right here, and then we can just change some modifiers on it, see if we can make this a little bit tougher. Maybe go from 25% infill to like 50% infill, and we can try thickening it up just a little bit more too to help it out. But I think that the biggest change is going to be on this piece, just because that's what broke on both of them. This only broke on this one, and I don't know if it wouldn't have broke if this part didn't, but I don't know. We'll see. I'm gonna make those changes and then we'll get back to it. Alright, so where we last left off, this is what the CAD looked like. And what I've done is I've gone through and I've made some changes which are going to make it just a little bit stronger. I've also changed some settings on the slicer to make it stronger. And if this doesn't work, I've got some more ideas, but I'm really hoping that this is going to work. So going over to the new file here, we're going to just kind of roll back through some of the changes that I've made, and then I'll be able to show you exactly what's happening. So I'm going to just delete all this stuff that we don't need, and then go back to here. So first off, I started with this move face command, which is just making this area here on the adapter a lot thicker. That's going to be able to support the weight better and just generally be stronger. Then I went down and I cut off this edge here because it's going to be printed inside of this orientation. So without this, that's going to be a pretty bad overhang area that will need to be supported. With this, it's not going to be overhanging anymore. I'm still confident that it's going to be able to sit on there and hold properly with this hole. The next step after that was cutting a slot into this hole to make it more of a teardrop type shape. That's just going to make it so the whole top of it doesn't bow down from the filament bridging, and it's going to just be able to go at a nice 45-degree angle upwards. That's going to be a lot nicer for us. After that, I went and added these two, which are just going to be like a little bit of an end stop for it whenever you're sliding in, to make it easier to do without having to look at it. And it's going to add a little bit of strength, but really not too much. And then on this part, which is the holder, I added in this, which I'm calling the holder mod. That's going to be a modifier inside the slicer to just make this area where it broke last time, so right in here, 100% infill instead of just like 25, or I'm doing 50% on the rest of it for this next version. But for this specific area, I'm going to be really, really solid. So I'm going to just do 100% there. It's going to take a little bit longer to print. It's going to cost a little bit more in material costs, but I think it could be worth it just for making this really, really strong right there. So then I'm going to do a modifier here as well. So you can see that I also added this adapter right here. And with all of those changes, I'm pretty confident this is going to be strong enough. I also, if you look at this, from here to here is 26 on this one, and then on this one, it's only 24. That's because I went ahead and added 2 additional millimeters here just to even beef it up just a little bit more for it. And if this doesn't work, maybe PETG isn't the best thing to put your entire body weight on from like a Walmart pull-up bar here. The only part that I'm still kind of concerned about is this area right here. It hasn't broken yet, but if there's one more point on this that I think could potentially be weak, it'd be that right there. I'm not going to change it right now, but that's the only thing left that I'm kind of a little bit concerned about. So going into the slicer, I'll show you what settings I've changed. So you can see under objects that I have the adapter and then the adapter mod, which is yellow. All you do to change that is just right click it, change type, go to modifier, and underneath this setting I'm making 100% here and then also 100% here where it broke on the other one. So we go to the sliced file, you can see that this is just fully solid over here where it broke last time, and then the rest of it's 50% gyroid infill. And then on this one, this area right here is fully solid while the rest of it is also gyroid infill. So I think that should be good.
The only thing that I would consider changing is maybe changing the holder mod from 100% infill to just like 99 walls and see what that looks like. But past that, I really feel like this is going to be pretty solid. I addressed the 2 areas where it broke, and I think it should be good to go here. But yeah, so 9 hours of print. I probably won't be able to see this at all until after Christmas, but hopefully this is a solved problem. We can actually go ahead and start looking at it whenever I get back. Yeah, I'd rather do the infill than the solid walls. So it's making it look like 2 different shapes. But yeah, we'll go from there. All right, here are hopefully the last 2 parts. Coming off the P1S, 0.4 millimeter nozzle. They've been sitting here for like multiple days, and these feel pretty chunky. They got the 50% infill gyroid, and then has part of it on each of these is just completely solid to make it really hard to break. And I think this might be what we need to make it actually support my entire body weight. So I'm going to put the holds on this, put it up on the pull-up bar, and I'll do the hang test for you. See if we're finally done with this project or if we had to make some more modifications. Alright, this is hopefully the last hang test. It's already up here. And I'm going to do the exact same thing as last time. Hang mostly on the right side, which is what caused it to break last time. And then see what happens. So starting out kind of in the middle, hanging with both hands. It's working good. Then I go a little bit more to the side, and it's rotating, so we don't like that. And let me get this tight, and then we'll try again. Okay, that's really cinched down. I think it should hold this time. So putting it back on, and then got my glasses on. We'll see what happens. That seems, I think that's good. I'm gonna put all my weight on it, but I was grabbing on the side here, and it's not rotating, and it didn't snap. So now I'm going to put my entire body weight here, mostly in the middle, and we'll see how this works. So, going on it. Okay, just this hand, like this. She's good. Oh my gosh, she's good. It looks fine. Looks totally fine. I think that the extra filament, that's what it needed, just beefing up those areas. The 100% infill, all of that, like that is solid. Okay, I'm gonna try on the other side. Shouldn't change anything, but just to try. Let's see. So just going straight into it. She is solid. All right, so that's it. The file works. I can fully support myself hanging on just that. Hanging on the edge, it doesn't rotate because of the teeth there once you get tightened down enough. And this is definitely going to be something that'll be useful for me when I'm developing rock climbing holds. Right now I'm using the TPU hold on the PETG high flow base right here. So that's what the teeth and the holder's made out of, and then the hold's actually TPU. But I'm confident from my other tests that you should be able to get this clamped down with the PETG or POA ones as well. If you're interested in checking out the files, I will have those posted down in the description. If you're interested inside of seeing more long videos like this, leave a comment down below. And that's about all. Thank you for watching.